The highest point of potential energy is at the top of the stairway where we begin to drop the marble. As we drop the marble and it begins to roll, that is when we see the highest point of kinetic energy. That is also when Newton's first law takes place, by staying in motion until it hits the end of the stairway and turns. Then it goes down a ramp made of aluminum foil. This point is the lowest point of kinetic energy because the marble is traveling at a slow rate. After it hits the aluminum foil, the marble hits the wall and falls through a hole, which transfers the marble to the next ramp.
While the marble is traveling down the second ramp, we created speed bumps by adding friction to slow down the marble. As the speed bumps reduce the speed of the marble, it has a negative acceleration. It then goes through a tube connecting to the second stairwell, which also contains speed bumps. We also created a stopper which applies to Newton's second law by using a force that pushes on the marble, causing it to slow down. It continues down the stairwell with a positive acceleration.
The marble then goes through the loop with a negative acceleration. After it gets through the loop, it rolls through a tube with positive acceleration. This causes it to jump from the tube to the cup. When it gets in the cup, it falls into a hole at the bottom and hits the dominoes. This causes an equal and opposite reaction, which is Newton's third law. This is also the lowest point of potential energy because it lands on the ground and is no longer in motion. As the dominoes hit the tack, it falls onto the balloon and pops it.